You good? Okay, so the Regenex e-bike integration is essentially just these coils in the e-bike that all produce regenerative acceleration above the critical minimum frequency of operation. So what we're doing is we're using the bike's drive motor to drive the generator. Obviously, part of what needs to happen is the throttle needs to be married to a post DC circuit, so these coils are operating as motor coils. Not as, right now they're basically just parasitic drag core losses, and it's not ideal, but it's good enough for now.
How do you translate the speed? You've got a big speed increase to the...
Yeah, okay, so the frequency of the bike motor is about 500 hertz, okay? The frequency required by the Regenex coil, sorry, that's wrong. 500 RPM,
RPM,
sorry, 3,000 RPM. So that's what,
601.
yeah, so that's what we saw here, about 3,000. So yeah, this basically gearing is to ensure that these coils are operating at the right frequency.
You need that, so the critical speed, what defines the critical speed?
Sorry, what defines it?
The critical speed for the Regenex coils.
So the critical minimum operating frequency of the coil is dictated by it's the impedance of the coil. Okay, the impedance of the coil is that's the AC resistance of the coil, and the impedance of the coil. The impedance of the coil dictates how much current can flow in the coil. If the frequency is too high, the impedance is too high, the current can't flow in the normal time space as it would with a conventional coil, because a conventional coil with 0.1 ohms, the impedance is always so low that current will always flow, pretty much. But with the Regenex coil, and also because of the way the Regenex coil is wound as well, it obviously produces a different result. And so what I'm going to just show you here is basically that in e-bike, and I'm just going to play around with quantum motor operation and Regenex generator operation. Each coil is connected individually to the e-bike's battery. Individually to their 6 lead-acid batteries in here. So each coil that we're using, the 3 different coils, there's 5 coils. Some of the coils are connected in parallel. And so let's fire it up. And this e-bike has cruise control. So once I bring it up to 30 kilometers an hour, okay, the speed is set, and then we go into regenerative acceleration, quantum motor operation, and then I'll bring it down to about 15 kilometers an hour, below the critical minimum frequency for the coils, and we have regenerative braking. So, actually, if you guys just want to sit down and I'll just go over, make sure I cover everything here. Generator armature reaction, EV regenerative braking, regenerative acceleration, quantum motor, rotational equilibrium. Okay, flux harvesting we didn't cover, but we'll leave that for now. We showed the conventional generator operation on all three prototypes, and regenerative acceleration, the critical minimum frequency. Above the critical minimum frequency you get regenerative acceleration, and below you get regenerative braking. So the technologies that need to be developed are Regenex generators, permanent magnet Regenex generators, field excited Regenex generators with electromagnets on the rotor rather than permanent magnets, a DC generator with a commutator. So on that prototype there, these brushes allow this motor to, this motor, deleting this, just using it as a drive shaft. This allows these coils to be motorized through a commutator. And so eventually what would be needed is a brushless motor, EV traction motor, and a brush. And regenerative acceleration motors for e-bikes, scooters, motorcycles, cars, and the pulse motor circuit, and the CPU for electric vehicles that dictates the function, the ideal function for the coil.
Okay, so a question.
Yeah?
Let's say we wanted to focus on this application. How much of this needs to be developed in order to make this application?
Okay, so right now, water rotor was here, and we know that we saw here the thing you developed for water rotor.
Yep.
Water rotor wants a Regenex, 1 kilowatt Regenex generator for the water turbine. What we're going to need to do is, based on how much funding we have available, and everything is going to dictate on how much funding we have available. That's going to decide. That's going to dictate what we're going to do. Is it? Are we just going to produce, permanent magnet Regenex generators? So, are we going to produce Regenex motors? Are we going to produce full electric vehicle systems? Ideally, I want to do everything, but it's based on how much money do we have.
Okay, so how much money you have is based on in the return of the investment. So
Yeah.
you need to, so okay, if you're going to build a motor, how is the investor going to get a return on his money if you just...
Okay, so what we're going to do, what we want to do is basically put the innovation into an e-bike, potentially this e-bike,
Right. Okay.
and demonstrate its viability on the road.
What does viability look like on the road?
Well, this e-bike's been on the road. So again, what it would do is demonstrate that the e-bike is able to, number one, recharge itself without deceleration while it's driving. Number
Does
two,
it recharge itself only during an acceleration phase with this, or is it
no,
constant velocity as well?
yeah, constant velocity. So again, with this, with these coils the way they are, the e-bike needs to be above or at 30 kilometers an hour.
Right.
Once it's at 30 kilometers an hour, the coil function, regenerative acceleration, can kick in, and once you have the EV, the inertia built up in the EV, once you have that, then, and you're not accelerating, then if you have two motors in the EV, one of them can be a regenerative acceleration generator. And it can supply basically, power to the batteries.
So
Yes.
is it, like, in terms of a straightforward demonstration, would you be able to take one of these bikes without it? Drive a certain distance?
Yeah.
And then add this component or a separate bike and demonstrate you can drive further on the same
Yeah,
energy, same charge or whatever? Or,
yeah, you don't.
and that would be a fairly straightforward demonstration. Right?
Yeah.
Like it's not, you can't, it's not something that you can fudge or anything like that.
Yeah, and the range on this e-bike with lead acid batteries is pretty low. It's
Okay.
like,
And is that actually, so you said you've actually taken this out on the road? and-
I've taken it on the road just to see if it would somehow decelerate when it's
So-
on the road.
I mean, what you need for investors is to, like, first of all, you do that demonstration, but it sounds like you're on your way to it's a fairly straightforward demonstration, but then it becomes a question of how much does it cost to package what you've got here into something that's commercial, right?
Yeah,
And then you take that to your investors and say, here's what it's gonna cost.
yeah, and the yeah.
And what the potential return is astronomical maybe, or who knows, but.
well, I don't think we're gonna get away with a full integration. Eventually, this goes into the hub motor.
Mm-hmm.
Now, that's not initial, but that's where it's eventually going to go. And then the hub motor is the replacement hub motor for all of these EVs, because now you have regenerative acceleration.
Can you create the coils in such a way where you have both regenerative acceleration, braking, like you mentioned, and provide the power to drive the wheel?
Yeah,
That's
not with one coil. If you have three coils, one coil could be a motor coil, one could be regenerative acceleration, and one could be regenerative braking. Okay? So again, and the CPU will decide. Ideally, this bike was supposed to have a generator on this side and a generator on this side, 24 coils. And the stage where it's at right now is that the coils, number one, they have to be motorized, and number two, the motor circuit has to be integrated into the throttle, so that it's working in concert with the drive motor. And that's how it has to be on any EV. And again, we're at the basic introduction stage here, introducing the innovation to you guys. And then once you guys become familiar with what's going on, then we talk to the investors, we decide how much we want to invest and how far we can go with the investment that we have. So that's where we're at.
Why only the 4 coils right now? I think I remember before you had a lot more in there.
These coils, the cores came from a partner we have at a generator company in California. So they supplied the coils, they had the coils wound,
Okay.
and there's 5 coils in this one.
Oh, yeah, sorry,
Yeah.
there's one at the top, right, okay.
So the RegenX coils, they all have to be on the same magnet polarity. So in this prototype here, so each coil is on a North Pole magnet, okay? And I don't know if you noticed, when we were delivering about 3 amps from this coil, and then I put the other coils into quantum motor mode, and again, I can do everything again, the current increased from 3.3 to 4.5, okay? What's happening there is, and that's why these are situated where they are, what's happening when coil number 3 is delivering power to the battery, and coil number 2 and coil number 4 are in quantum motor mode, the discharging magnetic field that's being produced by these coils is being collected in the core of coil number 3. That's why its output is increasing. And so that's flux harvesting. We're taking the flux from this coil and this coil, and it's being inductively delivered into this coil. So now this coil is being excited by the permanent magnet, rotating magnetic field, plus the electromagnetic field that's created around these coils. And these coils, coil 2 and coil 4, are accelerating the system, but they're also adding electromagnetic field energy into coil number 3. Now, I'm bringing that up because I'm answering your question. So, because of the nature of the coil, okay, they all have to be on the same magnet polarity, and they all have to be top dead center, which means that if you want to come and try and turn this, like if you turn
When you
this,
say they have to be on the same magnet polarity, they can't be on successive magnets because the magnets are flipping every time.
yeah,
Like if I take one magnet in the disk and the next magnet is south, north, south, all the way.
yeah, you can't. So usually what they do in a typical motor or generator is they'll put one there, and then they'll offset the next one right in between the 2 magnets to basically balance the cogging torque. And then they'll take another one, they'll put it 33 degrees or whatever. They'll stagger the coils so that this is a permanent magnet generator. This one is too. But it's almost like you don't feel anything because the cogging torque is very low.
Right.
This one, the cogging torque, you can feel it, but this one you can't. Now, with the nature of the RegenX coil, you can't stagger the coils. Because if you do, what'll happen, like if you tried to build it like a normal motor, okay? And if you had one over here in between the south and the north. As soon as you engage, if you engage this coil, and then you engage that coil, the electromagnetic field around this coil will reduce the output of the first coil, rather than increase it. So the
What's that proximity based on? Is it based on proximity, or is it?
Just through trial and error and development and so on, because of the load current delay, whatever the conditions are that produce the load current delay, it also dictates that all of the coils on a rotor, if you're looking at it from the front, they all have to be on the north pole, and they all have to be top dead center, not slightly offset. They all, now, from a motor perspective, that produces an extremely powerful motor, because now all of the coils and all of the magnets are being, like, they're getting the maximum amount of flux, rather than the flux coming at an angle. But it means that for a generator, and that's why this was designed to have another one on the other side, if all the coils on this one are in the same physical position, this rotor has to be offset by 50%. And they're connected to the same drive shaft, so that's how you reduce the clogging torque. You have to do it.
When you say 50%, you mean half magnet?
Yeah, just offset by half. Like, again, if all of these are all lined up symmetrically to the North Pole magnets on this side, all of these coils would be right in between. And then if you had a third rotor,
And the reason for that is to reduce clogging torque?
that's to reduce, that's because, that's to get a generator that turns like this, rather than one that turns like